Okay, guys, today what I want to do is I want to explain to you how the autonomic nervous system affects cardiovascular function. Specifically, I want to talk to you about how the sympathetic and parasympathetic nervous system affect heart function. As we recall from the first couple weeks of studies, I asked you to explain the effects of the sympathetic nervous system. So this is where knowing that is going to help you, and it's also going to come back to you. So remember that the sympathetic nervous system is involved in the fight or flight response, and its purpose is to prepare your body to run or fight. Now, again, and this is review, as you can see, all the spinal nerves of the sympathetic nervous system, when they exit the spinal cord, they all come together and they meet in series. So what that means is that when you activate the sympathetic nervous system, you don't activate one part of it, you activate all of it. And the purpose of it, again, is to prepare your body to run or fight. Now, we know that under sympathetic stimulation, your heart rate and your blood pressure are going to go up. What I want to know specifically is how that works. In addition to that, I want you to be able to explain how the parasympathetic nervous system affects heart function. So if you think of the autonomic nervous system, the sympathetic and parasympathetic divisions of the autonomic nervous system, think of the sympathetic nervous system as the accelerator. It's going to speed things up. And the parasympathetic slows things down. So that's kind of like the brake, okay? And the big nerve that affects the heart is called the vagus nerve, cranial nerve number 10. All right, you learn that in general, you learn the cranial nerves. So what I want to do now is explain to you how the sympathetic nervous system and the parasympathetic nervous system affect cardiac function. Now, here's a real simplistic drawing. Let me show you where you're at. Here is the heart cell membrane, and then we have some ion leak channel, sodium and calcium ions. And then we have a beta-1 receptor. And then we have the sympathetic nerve. Now, you remember from general that the sympathetic nervous system, or nerves in general, when they communicate with another nerve or a cell of the body, they don't directly touch. They don't come in contact with each other. They form what's called a synapse. And in order for the sympathetic nervous system to communicate with the heart, it has to release a specific neurotransmitter. And the neurotransmitter of the sympathetic nervous system is norepinephrine. So norepinephrine, norepi, that's the neurotransmitter. Epinephrine is the hormone. Now remember that hormones amplify the effects of the nervous system. So in this case, when the sympathetic nervous system is stimulated, it's going to cause the release of the neurotransmitter norepinephrine, and it's also going to stimulate the release of epinephrine from the adrenal medulla. And then that epinephrine is going to have a more profound effect on your body as well as the cardiovascular system to kind of amplify the effects of the sympathetic nervous system. So let's say, for example, that you get scared. And when you get scared, you're going to produce an electrical impulse that's going to travel down the axon of that sympathetic nerve. And then it's going to cause the release of the neurotransmitter norepinephrine. And norepinephrine then is going to float through this little space and bind to this norepinephrine receptor, or this beta-1 receptor. Now, when norepinephrine does that, essentially what happens is that it allows the heart cell membrane to be more leaky to sodium and calcium. Now, if you recall from question number 9 on the study guide, how the heart develops and sustains and maintains its electrical activity, we learned that you have a resting membrane potential, right? So that's the charge inside the heart cell when it's not doing anything. And we also learned that sodium and calcium are naturally leaky to the heart muscle cell. So when sodium and calcium leak in, when enough reach it, it's going to cause depolarization of the heart, or the heart's going to produce an electrical activity and ultimately cause the heart to contract and push blood out to the cells of the body. So under sympathetic stimulation, when norepinephrine binds to that beta-1 receptor on the heart muscle cell, it's going to cause more sodium and calcium to leak in. And if more sodium and calcium leak in, that means it's going to take less time for that heart muscle cell to reach threshold. And if the less time it takes to reach threshold, that means it will fire more frequently, so you will get an increase in heart rate. Now, we also know that calcium is the most important element in muscular contraction. And the more calcium you have, the more calcium can bind to troponin C, and the more myosin heads can bind to actin, and the more connections you make between actin and myosin in the heart muscle, the harder it will contract. So if the heart contracts harder, that's going to increase the pressure it can produce, so you're going to increase your systolic blood pressure. So this is how the sympathetic nervous system affects the heart in terms of increasing your heart rate and systolic blood pressure. And it does this by increasing the leakiness of the heart cell membrane to sodium and calcium. So if more sodium and calcium leak in, that means that the heart rate's going to go up. And because more calcium's coming in, the force of contraction is going to go up, so your blood pressure is going to go up. And those are the things that you want when you stimulate the sympathetic nervous system, because it's preparing your body to run or fight. And when you run or fight, your heart rate and blood pressure go up. So the sympathetic nervous system and epinephrine are priming the cardiovascular system to get you ready to run or fight. Now, a couple of terms, and again, nurses and doctors, they use these big terms, so I want you to become familiar with them. The combination, so both norepinephrine and epinephrine, are referred to as catecholamines. So when you hear I think I'm spelling it right. I think this is an E. Catecholamines. All right. So norepinephrine, the combination of norepinephrine and epinephrine, are referred to as catecholamines. And again, anything that stimulates a particular receptor, anything that stimulates a particular cell receptor is called an agonist. And anything that blocks a particular receptor is called an antagonist. All right. So norepinephrine is referred to as a beta-1 receptor agonist. It's going to stimulate it. So a beta blocker, right, that we talked about, that would be a beta-1 adrenergic antagonist. It's blocking that receptor. So that's the effects of the sympathetic nervous system. And again, we know that it increases your heart rate. What I want you to be able to understand is how it does that. All right. So that's sympathetic. Now let's look at the opposite of the sympathetic, and that would be the parasympathetic. And the big nerve of the parasympathetic division of the autonomic nervous system is the vagus nerve, right? So the vagus nerve innervates your heart. And again, you always have some sympathetic stimulation and you always have some parasympathetic stimulation. When you're scared, you simply have more sympathetic, but you always have in the background that parasympathetic stimulation. And the opposite is true. When you're resting and digesting, then you have more parasympathetic, but you still have the effects of the sympathetic. Now, the neurotransmitter for parasympathetic stimulation is acetylcholine. And any nerve that releases acetylcholine as a neurotransmitter is referred to as cholinergic. So you're going to hear these terms, adrenergic and cholinergic. Adrenergic refers to the sympathetic nervous system. Really, it also refers to the adrenal gland, right? So we know that epinephrine is released from the adrenal medulla. So adrenergic, sympathetic, cholinergic, parasympathetic. And again, the neurotransmitter for parasympathetic stimulation is acetylcholine. Now, remember that the resting membrane potential inside a heart cell, and who cares what that number is? It doesn't matter, right? It's a negative charge inside that cell. So if something were to cause the resting membrane potential to rise closer to threshold, then it would take, like if it was here, it would take less sodium and calcium to reach it, so your heart rate would go up. Now, the opposite is true. If something were to cause the resting membrane potential inside the heart cells to be lower than normal, then that means it would take more and a longer time for enough sodium and calcium to leak in to reach threshold. So that would drop your heart rate. So in the case of the parasympathetic nervous system, this is exactly what happens. So under parasympathetic stimulation, for example, strong emotional events, like you see a really bad accident or something like that, or you see someone that you care about, they're in the hospital and they're not doing too well, and you look at them and you get this strong, emotional feeling like grief, right, or sadness, that can stimulate the parasympathetic nervous system. And when you stimulate that, you're going to stimulate the vagus nerve, and that's going to cause the release of acetylcholine from the vagus nerve, the end of the vagus nerve. And when acetylcholine binds to that acetylcholine receptor on the muscle cell membrane, it causes more potassium to leak out. So potassium becomes more leaky. And remember, potassium is involved in repolarization of the heart. So if more positive things are leaving, the inside of that heart cell membrane is going to become even more negative. As a result, what that's going to do is that's going to lower that resting membrane potential. So inside the heart cells, the resting membrane potential becomes even lower than normal. So what that means is that it's going to take longer for sodium and calcium to leak in until it reaches threshold. Now, we also learned that cardiac output, or how much blood the heart pumps each minute, is determined by your heart rate times your stroke volume, or the amount of blood ejected with each beat. So remember that the goal of the cardiovascular system is to maintain cardiac output, or to maintain blood flow. So if your stroke volume stays the same, but your heart rate drops because of the stimulation of the vagus nerve, that's going to cause cardiac output to drop. And then that's going to cause you to drop. You're going to pass out. So what do? You lift up their legs when they pass out, more venous blood back to the right side of the heart. And when you stretch the right side of the heart, that is going to increase your stroke volume, so you will wake up. The other thing they do is they give them smelling salts when they pass out. And when you smell something that's bad, that stimulates the sympathetic nervous system, and that's going to cause your heart rate to go back up. So they'll wake up and say, hey, what happened? So that's the effects of the parasympathetic and sympathetic nervous system. Now, a couple of things about this clinically. One of the things that you will run into, especially in young, healthy people, if they're young and healthy and you stick a needle into their vein, that can stimulate the vagus nerve, and that can cause a drop in heart rate. And as a result, those people can pass out. So if someone says to you, and you're about to draw their blood, that, oh, I don't like getting my blood drawn, I've passed out before, then you lay that person down. Don't have them sitting up while you're drawing their blood. And then just have them get up very, very slowly so that they don't pass out. All right? So that's the important thing clinically too. The other thing is, if somebody has a really, really rapid heart rate, you can tell them to take a big deep breath and bear down like they're taking a dump, right? So when you bear down, right, when you hold your breath and you bear down, you do that Valsalva maneuver, that can stimulate the vagus nerve and drop your heart rate. That's why a lot of elderly people, you find them passed out in the toilet because they have constipation. They're on the toilet, grunting and groaning, right? They Valsalva, that stimulates the vagus nerve, drops their heart rate. They can't maintain blood flow to the brain, and they pass out. So a lot of times you'll find people, elderly people, passed out in the bathroom. So that's the effects of the sympathetic and parasympathetic nervous system on heart function. And I want you to understand what happens to potassium under the effects of parasympathetic stimulation. And then I want you to understand what happens to sodium and calcium under sympathetic stimulation. All right? I hope that helped.